So in this video we're going to learn about some new methods to form alcohols. So in particular, this new methodology we're going to be utilizing involves organometallic reagents. It's kind of, as the name implies, it's sort of this hybrid between organic and inorganic chemistry. In particular, it's these compounds with a carbon-metal bond. And in general, what we see here with these carbon-metal bonds is as carbon bonds to the metal, the carbon itself has become partially negative and the metal is partially positive. So we sort of, in essence, generate this carbon nucleophile, which we don't typically see from carbon. So two examples of this is, one is the Grignard reaction, in forming Grignard reagents. And what that looks like is the following, where we have some carbon, represented by R, and then some halogen represented by X. And what we do is we introduce magnesium and some sort of ether as the solvent, which is inert and doesn't do anything. And so when we react these two together, what we have actually is the magnesium inserting in between the carbon and halogen, making our carbon source nucleophilic. And on the opposite side of the, not opposite, but it's sort of an adjacent metal here with lithium, we see something similar where we have a alkyl halide, and I'll give a legitimate example, and we have some source of lithium and also an ether solvent down below. What we actually get is the following, where lithium itself has attached directly to the carbon, and we generate lithium bromide as our sort of non-reactive side product. It doesn't take place in the reaction in any way, but it's sort of, electron and atom bookkeeping here. And this difference, see, lithium is bonded directly to the carbon, while magnesium is not, and that difference comes from magnesium being 2+, and lithium being singly charged. And lithium, remember, is right underneath hydrogen on the periodic table, so that positively charged lithium is really harsh, it's real reactive. So it's going to easily make this carbon-lithium bond here, again, to make carbon nucleophilic. So let's look at a mechanism for this, for how this sort of reaction goes. And we can do a lot of these Grignard reactions and lithium reactions with any sort of aldehyde or ketones. Okay, there's a lot we can do, so we'll see some examples of this further in class. And this is similar in a lot of ways to the acetylide reaction, with that negatively charged alkyne, where we generate alcohols. But now we're kind of doing it with carbon and metals. So we start off with some ketone. Again, this could also be an aldehyde. And we have a dipole moment happening here, where that sp2 carbon is pretty electrophilic. And let's say we have some Grignard reagent, like so. Again, remembering that carbon, is nucleophilic now, so it will react with that electrophilic carbon, generating us our intermediate here. So we now have an O-, and this MgBr component is sort of hanging off there, and we have our carbon, that CH3. And I'm drawing in that carbon very explicitly here. And next, we have our O-, and similar with that other reaction that we had with the acetylide reaction, we introduce H3O+, which we're going to start seeing a lot, to neutralize our product here. We have that O-, and we're reacting it with this source of H+ to get our alcohol. Okay, and this is CH3. That's where that CH3 came from. So this is one way we can utilize these metal reactions for doing addition reaction, we're adding carbon to ketones or carbonyls in general, ketones and aldehydes. All right, so let's look at some specific examples here and try to make sense of them. right? So when we're looking at these two different reactions, right, we're being asked what are the reagents for number one, and what's the product for number two. And so for the first one here, what we have to consider, right, is what has happened, right? What's changed between the starting material and the product. Right, we can see here that, right, we no longer have a bromine, and we have a new carbon-carbon bond, okay? And so when we have, right, a new carbon-carbon bond, we can usually think, okay, there's some sort of organometallic reaction that has taken place. Right, some way that this new carbon-carbon bond has been generated, right? So we can sort of think of it like this, where this whole portion here, right, this carbon, this alcohol, all attached together, this must be one of our reagents. Okay? Again, right, we're learning about these carbonyl reactions, right, these aldehyde ketone reactions, so we know that the source of alcohol here must come from the corresponding carbonyl. Right, this is the only reagent that makes sense to form this reaction. So what are the steps we need to introduce? Right, we have to do this magnesium ether reaction, right, to form our magnesium bromide to make that carbon nucleophilic. Then we have our carbonyl here, right, which this magnesium bromide reacts with to form our O- intermediate. And then we finally use acid, right, some form of H+, to neutralize it to get our alcohol. And for number two here, we're looking at a different sort of organometallic reaction, right, with that lithium here, remembering that our carbon, right, is partially negative and this lithium is partially positive, right? So this carbon here is nucleophilic. And down below, we have a source of hydrogen, right? This NH4 plus Cl minus. So this NH4 plus here is our, right, source of H plus. Right, so kind of the same thing at the top, right? This nucleophilic carbon is coming in and right, breaking open that carbonyl, and we're acidifying it, right? We're quenching it at the end to form our alcohol, and then, right, the rest of this molecule, right, the rest of our reagent here has attached to the carbon, right, which we can illustrate like this. Actually, there's one extra set of carbon there. Here we go. Yeah, we want to make sure we're counting our carbon, right? So we have 1, 2, 3 carbons that we've added, and here we see we have 1, 2, 3 carbons we've added, right? And that's it. Right, so these are kind of new reactions that we're kind of getting used to. So we're going to have to sort of train ourselves to think in this way, right? Where we see a ketone, right? We know this carbon will be attaching here, and we're finally ending up with the neutralization of the O- to the alcohol. Okay. All right. So we have a couple more examples here, but we'll do these in class. Okay. So. Right, kind of the same thing as before, right? What are the reagents and what are the products for these two reactions here? And we'll do these together in class. But before we end the video, we're going to look at two more quick examples of these organometallic reactions that are a little bit different but the same in a lot of ways. So next we're going to be looking at the substitution elimination reactions. And so we've seen with addition reactions so far, we go from a carbonyl to an alcohol. Right, but with substitution reactions, what we see is a transformation from a carbonyl to a different carbonyl. Okay, facilitated by a leaving group. Because we notice with these two reactions down here, they're not just carbons or a hydrogen, there are other groups now, right? And so the difference between these two, which we'll go over in a minute, is as follows, where we have acid chlorides, which is a carbonyl with the chlorine group here, and then esters. Okay, And each of these, right, essentially have a leaving group now that can leave during the course of the reaction. And we'll talk more about these in a couple chapters, but I just wanted to introduce them now and do some shorter reactions with them. All right, so for this first example here, right, what's taking place, what's happening? Well, we have, right, our carbonyl stays, again, because of this leaving group, and then it gets replaced essentially with, right, our Grignard reagent, organometallic reagent. This carbon has attached itself to this carbon. So what is the mechanism of that? What does that look like in these substitution reactions? Okay, so it looks like this, where we have, right, our acid chloride, we have our phenyl magnesium bromide, and what's happening is, right, same as before with the addition reactions, but now we have this intermediate here. Where we have a good leaving group, right? Chloride here is a good leaving group. Everything else on this molecule, right, is not. And so what happens is instead of forming an alcohol with H3O+, this happens first, where with this tetrahedral intermediate, and we call this a tetrahedral intermediate because this carbon, right, tetrahedral is sp3, we actually reform the carbonyl and the chlorine leaves, bringing us to, right, our product that we have listed up above. And this final step there, right, we see we're still using H3O+. That's essentially just quenching the rest of the reaction to make sure there's no negative charges left behind, right? Just sort of to bookend the reaction. But we don't form an alcohol because this reactive step happens quickly, right? Chlorine is a great leaving group. This O- will reform the carbonyl, right? And we can't have our phenyl group leave as a leaving group because that's a bad leaving group, right? But chlorine, right, is a good leaving group. So that's what facilitates the reaction, okay? And in a similar way, with esters, we see the same transformation take place, where we form a tetrahedral intermediate, and then finally we have our Grignard reagent sort of swap with it, right? It'll come in, the O- will form, and then we'll have our species down below leave as a leaving group, okay? And that's sort of facilitated by H3O+. The Grignard reagent here, right, it's sort of written wrong, should be actually CH3 MgBr. All right, so we'll look at some more examples of this in class, and we'll see more of this in general in a couple chapters. But right, it's kind of makes sense to introduce it now.